video on the FRQ for week 3 and how to do it. And some little insights on how you can generate points without doing as much, or where the points kind of come from. So take this first part, and the first part you're supposed to do is, first of all, you're given this curve, and it's really important that they reference this idea of a curve, because if they talk about the curve later on in the problem, know that they're talking about this equation. So that kind of gives you a clue when you are doing a problem like this. If they name something as the curve, or they name it as F, or they name it as G or something, that's what they're referencing for the rest of the problem. So in this case, when you look down further and it talks about the curve in part B, and it says the curve in part C, they're referencing the curve, which is given by that equation. So it's really important for you to note that, because that's an important piece to kind of go, oh, okay, that's what they've named it, then let's use that. So in part A, it says show that this is the derivative. Now you know that that's the result you should get. So you know that, but you do have to do a step in here to get that first point, and then you know this is the second point. But if you just simply write down this answer, you won't get anything. So the first thing you need to write down is you need to write down the derivative. Well, the derivative of this is 2x plus 8y times y prime is equal to, now the derivative of 7 is 0. Then you differentiate the 3x, so you just get 3y plus, now you leave the 3x and you differentiate y and you get y prime. Now, that's the first step. The next step, you know what the answer is. And you know that the answer is what they gave you. If you did everything right, you can just jump right to this answer without showing any work in between. There is no work for some secondary algebra step, even though practically speaking you might use an algebra step in here. But you don't have to for the answer. That, what I wrote there, is 2 points. Remember, you're trying to generate 7 points, six or 7 points. If you can generate 6 points on all these, you're in the game to get a 5 on the exam. So that's 2 points right there. So let's look at part B. Part B says, okay, show that that there is a point P with the x coordinate equal to 3, where the line tangent to the curve is horizontal. And then it says find the y coordinate. Now here's the key. If you have a horizontal tangent, the slope is equal to 0. So we need the top of that derivative, 3 minus 2x, equals 0. That's worth a point. Just writing that is worth a point. You didn't even do anything other than realize, oh, tangent, horizontal tangent, slope equals 0. The numerator has to equal 0. Great. We're looking at that. Now, if you keep on going with this, you know x is equal to 3. So we got 3y minus 2 times 3 has to equal 0. So 3y minus 6 has to equal 0. Y has to equal 2. Okay, so great. Now you have the second point. You show that that's suddenly the point. The point that you have now is 3, 2. But it says show that this is on the curve at point P. So the curve. So you got to show that this works in the curve, which is the original thing. So we'd go back to the top and we'd do 3 squared plus 4 times 2 squared equals 7 plus 3 times 3 times 2. And you just show that those two sides are equal. If you show those two sides are equal, if you just do the calculations on one side and you know you've done everything right, you technically maybe don't even need to do the other side. So 3 squared is 9 plus 16 is equal to 7 plus 18. So 25 is equal to 25, and that is the third point. That's 3 easy points. That's 5 easy points. Remember, you got 2 points for this one. You got 3 points for this part. You've got 5 points. And you've only really done, arguably, you've only really done one calculus step. That first step was calculus. I suppose knowing that the derivative is the slope of the tangent line, setting it equal to 0 is another one. But technically, I kind of think there's only 1 point for calculus on here. And then we get to the next part. And the next part is, okay, now that we've done all this work, let's look at part C. Find the value of d squared y over dx squared. Now that's suddenly at the point P you found in part B. You already know the point P is at this point 3, 2, so we're going to use that. But we need to calculate the second derivative. Well, that's using this derivative. We're just going to do the quotient rule. So we're going to do the low times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. That's 2 more points. Now we're at 7 points. Honest to God, we're at 7 points. We haven't really done much. We know that if we use that, we know y prime is equal to 0 here because that's the work that we did. This is the work we did from part B. So we know wherever there's a y prime, we can put 0 in because that's the work we found. Wherever there's an x, we can put 3 in. Wherever there's a y, we can put 2 in. And that's going to be another point. If we go through that, we go through here and we say, okay, the second derivative at the point 3, 2 is equal to 8 times 2 minus 3 times 3 times 3 times 0 minus 2 minus 3 times 3 minus 2 times 2 times 8 times 0 minus 3 all over 8 times 3 minus 3 times 2. Oh, sorry. Put those in the wrong place. Let me go back. Let me change some of those values. I put those in the wrong place. So this should be a 2. This should be a 3. Square that, and I think I put them in the wrong place up here too, so let's make sure this one's wrong and that one's wrong, and I think that's the only one. Let me make sure. Yeah. This is a 3, that's a 2, this is going to be a y, so that's going to be a 2, this is an x, so that's going to be a 3. That's worth a point. Now we're at 8. And if you do the calculations on that, you'll end up with that's negative 2/7, which would suggest that y is concave, or the curve. So what we know is the curve at the point 3, 2, the slope is equal to 0, so y prime, and is concave down. So if we have a concave down, slope equaling 0, that makes this a relative maximum. So since the first derivative is equal to 0 and the second derivative is less than 0, 3, 2 is a relative maximum. That right there is the final thing. And from there, you're done. It's a pretty easy problem.